This lecture is over 1.4, more on conditionals, so this week we have 1.4 and 1.5, so be a busy week. Create the converse, inverse, and contrapositive of a conditional statement, so we'll learn what a converse is, an inverse is, and a contrapositive. We'll determine equivalent variations of conditional statements, so nicely we're going to find out things about the statement, the converse, inverse, and contrapositive, and how they're equivalent to each other. Interpret only if statements, and then interpret a biconditional statement. So the order of components in a conjunction or disjunction makes no difference to the truth value of the statement. So I can say P and Q, and that's equivalent to saying Q and P. So the equal sign is equivalency. So this is not so with conditionals. If I say P implies Q, this is not the same as Q implies P. So let's look at some variation of conditionals. Let's say I had the statement P is you're compassionate, and the statement Q is you contribute to charities. So if I say P implies Q, that means if you're compassionate, then you contribute to charities. But if I have Q implies P, if you contribute to charities, then you're compassionate. Not P implies not Q. If you're not compassionate, then you do not contribute to charities. Not Q implies not P. If you do not contribute to charities, then you are not compassionate. So it turns out for any given conditional, and in this case we're looking at the conditional P implies Q, we're going to have three variations: a converse, an inverse, and a contrapositive. So let's look at the converse of a statement. So here, the converse of a conditional. So if you're given a conditional P then Q, P then Q, and this is really the important thing, the converse is Q then P. So Q then P, the converse is P then Q. So you find it by interchanging the premise and the conclusion. If you look, these two here are converses of each other. So if I switch the premise and the conclusion, I get the converse. P implies Q, Q implies P. So the converse, if P then Q, the converse of that statement is if Q then P. So you switch the order of the premise and the conclusion. The next thing we're going to look at is the inverse. The inverse is you're given something, get green. If P then Q, you're going to negate both premise and the conclusion. So the premise and the conclusion, the order stays the same, you just negate that. So not P implies not Q is the inverse of P implies Q. So if not P then Q. So really here we have if P then Q, if not P then not Q is the inverse. So here, if I look at these two statements, these are inverse statements. You notice P implies Q, not P implies not Q. So this is the statement, this is the inverse. This is the inverse of the inverse, is the original statement. So these two are related. The first one and the third one are the inverse of each other. And then the last thing we're going to talk about is the contrapositive. So here, if I have the contrapositive, in the contrapositive, you're going to negate and interchange both the premise and the conclusion. So we're going to negate and interchange. So if I have P then Q, the contrapositive is not Q then not P. So up here, if you look at the first one And the last one, these are the contrapositives of each other. So when you flip the order of the conclusion and the premise and negate them, that's a contrapositive. So important to know, the converse is just flipping the order. The inverse is just negating. The contrapositive is doing both. So if you see this little figure 1.55 in your book, gives you the 3 different variations of a conditional. So if you take a conditional, P implies Q. The converse is going to be, well, let me use the same color, it doesn't really matter. The converse is going to be P implies Q. Sorry. The converse of P implies Q. So let me write this way. The converse of the statement is Q implies P. You flip the premise and the conclusion. The inverse of P implies Q is going to be negating the premise and negating the conclusion. And then the last thing, the counterpositive or contrapositive, both ways are acceptable. You flip and negate the premise and conclusion. So this is important, that when you're given a conditional P implies Q, the inverse, the contrapositive, and the converse are standard like this. But let's look at an example when our statement or our conditional is something like not P implies Q. Then the converse is going to be Q implies not P. So you see I just flipped the premise and the conclusion. The inverse, oops, pen doesn't want to write sometimes. The inverse of this statement is going to be not P, so that would be P implies not Q. So I don't flip the order, I just negate the not in front of it. So if there is a not would go away, and this doesn't have a not, so it'd have a not. And then the contrapositive is going to be doing both. I'm going to flip it and negate it. So then I have not Q implies P. So this example is given for statements in the form P implies Q. But if your conditional is not in the form, it might be in the form not P implies not Q. If you're looking for the converse, you flip the order of your conditional and your premise. If you're looking for the inverse, you negate your premise and you negate your conclusion. And if you're doing the contrapositive, you do both. You flip them and you negate them from the original. So this is the original conditional. This will be given. So I hope that, or you'll have to find it by writing it in the statement. And I'll do some examples of that. A conditional and its contrapositive, for equivalency, it turns out the conditional and its contrapositive are always equivalent. So anytime that you flip the order, if you flip the premise and the conclusion and you negate it, you get equivalent statements. And then its converse and its inverse are going to be equivalent. So you notice, regardless of the specific content, every if-then statement has an equivalent variation formed by negating and interchanging the premise and the conclusion of the given conditional statement. So if you notice here, if I flip this and I negate it, I get the contrapositive. If I flip this and negate it, I get the contrapositive of the original statement. So anytime you negate and interchange the premise and the conclusion, you will get a equivalent condition. So here, if I flip them and interchange them, I get this. If I flip and interchange the original one, not P implies not Q, I get an equivalent statement. So that's something that's important to keep in mind as you're doing your homework. Anytime they ask you, are these two statements equivalent? If you write them symbolically and you notice that they are contrapositives of each other, then you have equivalent statements. Okay, so let's look at some examples that are still in the PowerPoint. Now, throwing in some things that we learned last week. So necessary tells me the order is going to be switched. So first off, I just want to write the statement, and then I'll express the contrapositive in terms of a sufficient condition and a necessary condition. So given the statement, being a doctor is necessary for being a surgeon. So let's say this is doctor and this is surgeon. So necessary means I switch the order. So being a surgeon implies you're a doctor. So this is the statement. The statement is being a surgeon implies being a doctor. So remember, necessary tells me I'm going to switch the order of premise and conclusion. So I want to express the counterpositive. So counterpositives contrapositive would be not being a doctor implies not being a surgeon. So now that I have the contrapositive, I'm going to express it in terms of sufficient condition. So sufficient tells me the same order. So not being a doctor is sufficient for not being a surgeon. So that's what we had here, right? Not being a doctor implies you're not a surgeon. So if I want to use sufficient conditions, I can use the same order. Now, if I want to use necessary condition, I need to write the order. Oops. What happened there? Something happened with my pen jump. So, if I can undo this. Okay, so with sufficient condition, I use the same order. And with necessary, I have to change the order. Again, necessary has to change the order. Now, so this would be not being a surgeon is necessary for not being a doctor. So not being a surgeon is necessary for not being a doctor. So let me see what's going on. Sorry, my computer is freaking out. Hopefully I got everything situated there. So this is a contrapositive of this statement. Not being a doctor implies you're not a surgeon. So if I want to use sufficient, I don't change the order of the premise and the conclusion. If I want to use necessary, I'm still writing the contrapositive, but if I want to use it saying necessary, I need to switch the order of the premise and the conclusion. So here I'd say not being a surgeon is necessary for not being a doctor. So hopefully that makes sense, and I'll do some more examples. Only if, we have to be careful when we have an only if here. If we have R only if S, we write that as R implies S. We're used to looking for if and then saying if the premise, then the conclusion. But if you have an only if in this statement, you would leave the order the same. R only if S. So R implies S. A biconditional is going to be when a statement is in the form P implies Q and Q implies P. This can be symbolized as these double arrows. P implies Q, Q implies P. And you can read it as P if and only if Q, And so frequently it's abbreviated as IFF, if and only if. So it turns out a biconditional is equivalent to saying if P then Q, and is equivalent to saying Q and P. So this biconditional is saying P implies Q is the same thing as Q implies P. If you want to use sufficient, P is sufficient for Q, it's the same thing, same order. If P then Q, P then Q. If you say P is necessary for Q, not the same order, not same order. I like to remember sufficient starts with S, so you have same order. Necessary, not same order, so you're going to flip them. So you can see here, you flip the order of P and Q, and you have if Q, then P. So hopefully this reiterates what we've been going over with necessary and sufficient. So therefore, the biconditional, if we have something P, if, and only if Q, this can be rephrased as P is necessary and sufficient for Q. If they want you to use necessary and sufficient in the biconditional case, you have to use both, necessary and sufficient. So let's look at some examples from the homework. Write an equivalent variation of the given conditional. A lot of times I like to write these symbolically and then see which one are a contrapositive of the statement. So you are criminal only if, so this is the only if, you do not obey the law. So we would have criminal implies you don't obey the law. And you can use your own symbols on this. But I know that an equivalent variation is going to be if you obey the law, you're not a criminal. Because this is the contrapositive of this statement, right? Because I flip them, I switch the order, and I negate them. So I have, if you obey the law, then you are not a criminal. So the correct answer, if you obey the law, then you're not a criminal. So hopefully that makes sense where you can see if you're looking for equivalent variation, you write it symbolically, and then you take the contrapositive of that. So remember, a contrapositive of any statement is going to be equivalent to the original statement. So translate the two statements in symbolic form and use a truth table. Again, using truth tables are really long. You don't have to use a truth table. You can just see if they're contrapositives of each other. So I cannot have surgery if I do not have health insurance. So this is just a straight if then. So I do not have health insurance. So no health insurance implies I cannot have surgery. So that is the symbolic representation of the first statement. If I can have surgery, then I do not have health insurance. So this one is, if I can have surgery, then I do not have health insurance. Then I do have health insurance. So automatically you can see they're contrapositives of each other. So the statements are equivalent. Anytime a statement is a contrapositive of another statement, the statements are equivalent. So you don't have to go through and make the truth table of these two statements to see if they have the same columns. You can if that is your preferred method. So let's look at this one. If the Giants win, I'm happy. So win implies happy. If I'm happy, then the Giants won. So happy implies won. If the Giants lose, then I'm unhappy. So not win implies not happy. If I'm unhappy, so not happy implies not win. The Giants lost. So if you notice, win, happy, not win, these are contrapositives of each other. So 1 and 4 are equivalent. These are equal. More so, these two statements are contrapositives. I flip them and I negate them, so these two are equal. So 2 and 3 are the same. So 2 and 3 are equivalent and 1 and 4 are equivalent. So there are more than one box you need to click on these. You could do a truth table and find these out, but again, it's going to take you so much more time than just writing them symbolically and noticing that they're contrapositive of each other. So hopefully at this point, these are getting more and more straightforward for you. If you have necessary tools, assembly time is less than 30 minutes. This necessary doesn't have any part of it. It throws them in there, so be careful. If you have the necessary tools, so if you have tools, the assembly time is less than 30 minutes. So tools assembly time is less than 30 minutes. So let's say minutes. So T would be defined as the necessary tools. So let me box this off. So T here is defined as you have the necessary tools. And let's say assembly time is less than 30 minutes. Let's call that M. So the statement is if you have the necessary tools, then the assembly time is less than 30 minutes. So if you want to find the inverse, so remember what the inverse is. And if you need to go back, you can. Here, the inverse is going to be when you negate the premise and negate the conclusion. So this would be, the inverse would be not T implies not M. So then if you do not have the necessary tools, then the assembly time is not less than 30 minutes. So if you do not have the necessary tools, then the assembly time is not less than 30 minutes. So we have that. The converse would be just switching the premise and the conclusion. So if the assembly time is less than 30 minutes, then you have the necessary tools. Contrapositive symbolically would be not M implies not T. Because remember, this is the original statement. This is what you have to deal with. Be careful, because this is again an if you do not eat meat. So the statement would be, let's say, not eat meat implies you are a vegetarian. So the inverse, remember what you do with the inverse, the converse, you know what you do, and the contrapositive, you know what you do. So be careful that you know your statements correctly. So this is, you do not eat meat. So do not eat meat would be M. Oh, sorry. Eating meat would be M, and this would be not M. And then you are a vegetarian would just be V. So the statement would be, if you do not eat meat, then you're a vegetarian. So the inverse, the contrapositive, and the converse, you should be able to write it symbolically and then figure out what it's saying in words. And this concludes 1.4. I'll also post 1.5 video. You can look at that. 1.5 is pretty much a review, so it should be pretty short. And if you have any questions, let me know.